All right, so buckle up, everybody, because today we're taking a deep dive that takes us right to the edge of the universe, or at least to the edge of what we currently know about it. We're going to grapple with a question that's really puzzled humans for, well, probably as long as we've been looking up at the stars. Does the universe have an edge?
Yeah, that's a great question. And it's one that leads to some really mind-bending paths, as I think you'll see from the excerpts you've shared.
Okay, so before we get lost in all of the truly cosmic stuff, let's actually start with something a little closer to home, something we can actually observe. You know what I'm talking about? The observable universe. So what exactly is that, and why is it so important for us to understand?
Well, you can kind of imagine the universe as this vast space that's constantly expanding outwards, right? So the observable universe is basically our limited view of that space. It's this bubble that's centered around us, defined by the distance that light has had the time to travel since the Big Bang occurred.
So it's kind of like our cosmic horizon in a way.
Mm-hmm.
But it's not actually a physical wall or anything like that, right?
Exactly. You got it. It's just the limit of what we are currently able to see. And this is where it gets interesting. Different telescopes can actually see different eras of the universe because they can actually detect different wavelengths of light. Think about the James Webb Space Telescope. It can peer into the infrared, so it's detecting light that has been stretched and redshifted over billions and billions of years, allowing us to glimpse some of the earliest galaxies in the universe.
Wow, that's really amazing. But even with these incredible telescopes that we have, I imagine that it's still pretty tricky to actually measure the distances and the ages of these objects that are, billions of light years away from us.
Oh, absolutely. It is a huge challenge, one where we need a ton of precision to get it right. We rely heavily on something called spectroscopy. That's basically analyzing the spectrum of light to avoid errors. As the universe expands, you see the light traveling through it gets stretched, and this shifts its wavelengths towards the red end of the spectrum. That's what we call redshift.
Okay, yeah, I've definitely heard of redshift. But what's so important about getting that redshift calculation right?
Well, just think about it this way. If we miscalculate the redshift, we end up with an inaccurate picture of how far away something actually is, and therefore how old it is. And even a small error in that calculation can actually snowball into a huge misunderstanding of the entire universe's timeline of how galaxies have evolved over time.
So like one tiny decimal point is off, and all of a sudden we think a galaxy is from a completely different era of the universe.
Precisely. And there was actually this fascinating case where an object was initially thought to have a redshift of 16. And that suggested that it existed just a couple of 100 million years after the Big Bang. I mean, it was practically a baby picture of the universe.
Wow, that would have been huge.
It would have been. But more detailed analysis actually revealed that the actual redshift was more like closer to 5 or 6. Still incredibly distant, don't get me wrong, but not quite as groundbreaking. This just goes to show how crucial it is to carefully validate those measurements and not jump to conclusions too quickly.
So, lesson learned when it comes to the distant universe.
Yeah.
Always double-check those cosmic measurements. Okay, but let's say we've accounted for redshift and all of that. Does the edge of the observable universe mean that there's like an actual edge to the universe? Like if we kept traveling outwards, would we eventually hit a giant wall somewhere?
Well, that's a pretty common misconception that a lot of people have, but thankfully that's not what our current cosmological model suggests. There's likely no such boundary in the four-dimensional space-time continuum.
Okay, so no cosmic brick wall. That's a relief. But how can we even wrap our heads around the idea of a universe that just doesn't have an edge? It's kind of mind-boggling, to say the least.
It is. Well, think of it this way. Imagine a two-dimensional being that lives on the surface of a sphere, right? They could walk and walk forever and ever, and they would never actually hit a physical edge. But we as three-dimensional observers can see that the sphere itself is actually finite.
So maybe the universe is finite, but our three-dimensional brains just can't quite grasp it.
It's a fascinating possibility for sure. And this is where things get even more intriguing. Not only is there likely no edge, but the universe is constantly expanding. And it's not just the stuff in the universe that's moving apart, it's space itself that is stretching.
Wait, so it's not like an explosion where everything is flying outwards from a central point?
Not at all, no. It's more like imagine a loaf of raisin bread dough that's rising in the oven, right?
Yeah.
Each raisin, and the raisins would represent a galaxy, in this case, is getting farther away from every other raisin, but there's no single center of that expansion.
Okay, I think I'm starting to get it. So every single point in the universe could actually be considered the center from its own perspective.
Precisely. Which also means that during the universe's early period of rapid inflation, the expansion might have been happening even faster than the speed of light.
Hold on, faster than the speed of light, but isn't that like the ultimate cosmic speed limit?
It is pretty mind-blowing, right? But it doesn't actually violate the laws of physics because it's not matter moving through space faster than light. It's space itself that was expanding at that insane rate. Think of it like stretching a rubber band with dots on it. The dots aren't actually moving themselves, but the space between them is increasing.
Okay, my brain is definitely starting to bend here a little bit. But all this talk of expansion, especially at those extreme early stages, it makes me wonder about the role of gravity. Wouldn't gravity have had a huge impact on all of this?
That's a fantastic question, and it leads us right to the edge of our current understanding. Einstein's theory of general relativity, which explains gravity beautifully on large scales, actually starts to break down when we try to apply it to incredibly dense environments, like the very, very early universe or black hole singularities.
So, we need a whole new theory of gravity in order to fully grasp what was going on back then.
That is the quest, my friend. Physicists all over the world are actively searching for what they call a quantum theory of gravity. It would be a theory that could reconcile general relativity with the principles of quantum mechanics. It's one of the biggest mysteries in all of physics today.
And what about this graviton I keep hearing about? Does that play into this quantum gravity puzzle at all?
Ah, yes. Well, the graviton is a hypothetical particle. We haven't actually been able to detect it yet. But if it does exist, it would be the particle responsible for actually mediating the force of gravity, much like the photon carries the electromagnetic force. And scientists are currently studying gravitational waves, those ripples in space-time that are caused by massive objects, and they're hoping to learn more about gravity's quantum nature and maybe, just maybe, even find evidence for the graviton.
It's amazing to think that by studying these huge cosmic events, we might actually unlock the secrets of gravity itself. But we can't talk about the structure of the universe and its evolution without talking about the elephants in the room here. I'm talking about dark matter and dark energy.
Yes. Two of the biggest mysteries in cosmology. They're called dark because we can't directly see them. They don't interact with light in the same way that normal matter does, but we know they must exist because of their gravitational effects.
So we can't see them, but we can see what they're doing.
Exactly. Dark matter, for example, seems to be what's holding galaxies together. We see its gravitational pull on the stars and gas, even though we can't detect the matter itself. And then there's dark energy. Now that's even more baffling. It's this mysterious force that's actually causing the expansion of the universe to speed up, to accelerate.
So not only is the universe expanding, it's actually expanding faster and faster, and we have no idea why.
You got it. That is the big mystery. There are lots of theories out there, of course. Some think that dark matter could be made up of some exotic particles that we haven't discovered yet. Maybe dark energy is related to a cosmological constant, or perhaps even some entirely new kind of field that permeates all of space. It's all very much an open question at this point.
Okay, my brain is officially hurting, but in a good way.
Yeah.
It's incredible to realize just how much we still don't know about the universe. But before we get too lost in the cosmic depths, I kind of want to bring this back down to our own little corner of the universe for a second. Where exactly do we fit into this vast, expanding web of galaxies and dark matter and all of that?
Well, our own Milky Way galaxy is actually part of what we call the local group. It's a collection of about 100 galaxies that are gravitationally bound together. And the local group itself is actually part of the even larger Virgo supercluster, which is just one tiny node in this vast cosmic web that extends across billions and billions of light years.
Wow, talk about a cosmic address. The Milky Way, the local group, the Virgo supercluster.
Yeah.
It really puts things into perspective, doesn't it?
It really does. And it just highlights how vast and complex the universe truly is.
Yeah. But if the universe keeps expanding the way we think it will, what happens to all those distant galaxies? Will they eventually just drift so far apart that we can't even see them anymore?
No, that's a question that really takes us to the very edge of what we currently know about the universe. And it's one that we'll explore further in the next part of our deep dive.
Okay, so we've talked about this incredible, ever-expanding universe and the fact that it probably doesn't have an actual edge. But you left us hanging there with that cliffhanger about those distant galaxies maybe fading from view at some point. What does it actually mean for us? For our understanding of the cosmos, if those galaxies were to just disappear?
Yeah, well, just imagine a future, right, where the light from those distant galaxies has redshifted so far that it's become completely undetectable, even to our most super advanced telescopes. We'd essentially be stuck with only our own Milky Way galaxy to study.
Wow. I gotta say, that's kind of a lonely thought. Like going from this grand panoramic view of the universe to basically staring through a tiny little keyhole. What would that do to the field of cosmology? Our ability to understand how the universe works as a whole.
It would certainly limit our perspective, that's for sure. And it would definitely force us to, rethink a lot of our current approaches. A lot of the techniques that we rely on today, like measuring the cosmic and microwave background radiation or observing those distant supernovae to track how the universe is expanding, all of that would become basically impossible.
So we'd lose access to some of our most powerful tools for understanding the universe. That sounds like a pretty major setback for science.
It would definitely be a challenge, yeah. We'd be left with this much more localized view. And trying to piece together that bigger picture, of the universe's history, how it's evolved over time, it would become much, much harder.
So, like, future generations of scientists might be stuck with an incomplete view of the universe, maybe even an inaccurate one.
It's definitely a possibility, but I also think it would spark incredible ingenuity. Humans are amazingly adaptable,
Right.
I can totally imagine future scientists developing entirely new technologies and techniques that could, maybe allow them to detect incredibly faint light that's been redshifted to extreme degrees, or maybe they'd find ways to study the universe through, gravitational waves or other phenomena that we haven't even fully grasped yet.
So it's not necessarily game over. It's more like, level 2 of the game has started with a whole new set of rules and challenges.
Exactly. And remember, even if we were limited to only observing our own galaxy, there's still an incredible amount that we don't know about the Milky Way itself. We're constantly discovering new stars, new planets, even entirely new structures within our galaxy.
That's a really good point. It's easy to get caught up in, the vastness of the universe and forget that there's still so much to explore right here in our own cosmic backyard.
Absolutely. And who knows, maybe by delving deeper into the intricacies of our own galaxy, we might uncover clues that could actually help us understand the broader universe in ways that we can't even imagine right now. It's kind of like, becoming an expert in a single complex ecosystem. That expertise can often shed light on the workings of larger interconnected systems.
Okay, that's actually a really encouraging thought. But let's just step back for a minute here and talk about some of the other theories that are out there about, the universe's ultimate fate. Earlier, we were talking about this idea of, like, perpetual expansion. But weren't there some other possibilities, too? Like, what about the Big Crunch?
Right, the Big Crunch. Yeah, that was a pretty popular idea for a while. It basically imagined a scenario where gravity eventually wins out over this expansion, pulling everything back together into a super dense singularity. Essentially like a reverse Big Bang.
So the universe would basically just collapse in on itself. That sounds pretty dramatic.
It does, yeah. But based on what we currently know about dark energy and the fact that the expansion seems to be accelerating, the Big Crunch just seems a lot less likely now.
Okay, well, what about the Big Rip? Now, that one sounds even more intense. What's the thinking behind that one?
Oh, the Big Rip is a wild idea. It basically suggests that dark energy could, at some point, become so incredibly powerful that it literally rips apart everything. Galaxies, stars, planets, even atoms themselves.
So it's like everything would just disintegrate.
Huh.
Okay, that's kind of terrifying, but I got to admit, it's also kind of awesome.
Yeah.
In a cosmic, destructive sort of way.
Yeah, it's definitely a very dramatic scenario. But like the Big Crunch, it's not really the most favored hypothesis based on the data that we have right now. Perpetual expansion, fueled by dark energy, still seems to be the most likely path for the universe, at least for now.
Okay, so maybe not a super fiery or cataclysmic ending, more of a slow, gradual fade into, like, cosmic isolation. But
Yeah.
you said based on current data there. So does that mean, like, our understanding of all this could still totally change? What if there's some other force or factor out there that we haven't even discovered yet? Something that could just, like, throw everything we think we know right out the window.
Well, that's the beauty of science, right? It's constantly evolving. It's a process. Our understanding of the universe has already changed drastically over the past, 100 years. And there's really no reason to think that it won't continue to change in the future as we learn more.
So the ultimate fate of the universe is still very much an open question. That's exciting.
Yeah.
And also a little bit unsettling at the same time.
Absolutely. And that's what makes cosmology so captivating. We're constantly pushing the boundaries of what we know, trying to piece together this immense puzzle of the universe's origin, how it evolved, and ultimately, how it will all end.
And who knows what incredible discoveries await us in the future. Maybe we'll find a way to overcome those limitations of the observable universe or unlock the secrets of dark matter and dark energy.
The possibilities are truly mind-boggling, but, even if the universe is ultimately destined to just slowly fade into darkness, I don't think that has to mean it's a sad ending or a meaningless one.
I love that perspective. It's not about the end. It's about that incredible journey of discovery and understanding. So where do we go from here? We've covered a lot of ground today. From the edge of the observable universe to those mind-bending ideas about expansion in space-time, the mysteries of dark matter and dark energy. We even touched on some of those potential fates for the cosmos, what they might mean for future generations of, cosmic explorers. So what are the key takeaways here for our listeners?
I think the most important thing for people to remember is that our understanding of the universe is always changing. It's fluid. What we think we know today might be completely overturned tomorrow. So it's so important to stay curious, to keep asking those questions, and be open to new possibilities.
So stay curious, keep exploring, and never, ever stop being amazed by this universe and all of its mysteries. Wow, we've really been on quite a journey, haven't we? Exploring the universe, from the edge of what we can actually see to all these mind-blowing mysteries about dark matter and dark energy and how it's all going to end. It really makes you realize there's just so much out there.
It really is humbling when you think about it. And like we've been talking about, the universe is constantly doing its thing, evolving, expanding, and just always throwing curveballs our way.
Totally. But before we wrap things up, I wanted to circle back to something you mentioned earlier. This idea that if the universe keeps expanding like we think it will, we could actually lose sight of all those other galaxies out there. So what happens to our whole understanding of the universe then? Are we just stuck with this limited, cosmic tunnel vision forever?
Yeah, it's an interesting question to think about, isn't it? Imagine future astronomers, right? They're gazing up at the night sky and all they see are the stars of our own Milky Way. It would be a pretty profound shift in perspective, I think.
Yeah, it'd be like, I don't know, going from exploring this vast, vibrant rainforest to just studying a single tree in your backyard. You might learn a lot about that one tree, but you're missing out on this whole incredible ecosystem.
That's a great analogy. And it really highlights, I think, the challenges that future cosmologists might have to deal with, think about it. A lot of the techniques that we rely on today to study the universe, on this grand scale, they would become totally impossible if those distant galaxies just faded from view.
We wouldn't be able to use those distant supernovae to measure the expansion rate of the universe anymore.
Exactly. And studying the cosmic microwave background radiation, that afterglow of the Big Bang, it would be much, much more difficult to study that as well. I think we'd be left with a really localized view and piecing together that larger story, the history of the universe, how it's evolved over time. It would become a really, really hard problem.
It kind of makes you wonder if we're living in this sort of golden age of cosmology, you know what I mean? We have this incredible window to see so much of the universe, a window that might not always be there.
Yeah, that's definitely a possibility. We might be living in this unique time when the universe is basically revealing all these secrets that won't be accessible to those who come after us.
But that doesn't mean those future scientists will just give up, right? Humans are amazingly creative. I can totally imagine them coming up with all sorts of, creative new ways to study the universe, even with those limitations.
Yeah. Oh, for sure. Necessity is the mother of invention, right? So who knows? Maybe they'll figure out how to build telescopes that can detect these incredibly faint signals. Or maybe they'll find ways to study the universe through, subtle variations in gravity or something. Or maybe they'll even learn how to exploit quantum entanglement for astronomical observations.
Now that would be mind-blowing.
Yeah.
It makes you wonder if those future discoveries, whatever they are, could end up completely revolutionizing our understanding of the universe, just like the invention of the telescope did centuries ago.
It's definitely an exciting prospect. But even if we are eventually limited to just observing our own galaxy, there's still so much that we don't know about the Milky Way itself. We're discovering new stars, planets, black holes all the time. We're even finding entirely new structures within our galaxy that we never even knew existed before.
It's like we've only just scratched the surface of our own little cosmic neighborhood.
Exactly. And who knows, maybe by delving deeper into, the intricacies of our own galaxy, we might actually find clues that unlock even bigger mysteries about the universe as a whole.
It's like it's all connected, right? The really small stuff to the really big stuff. What's happening here in our own little corner of the universe to what's happening billions of light years away. It's like Each new discovery, no matter how small it seems, adds another piece to that huge cosmic puzzle.
I love that. And that's really what makes all of this so fascinating. The universe is just this incredibly vast, interconnected web of wonder, and I think we're just barely beginning to grasp just how complex it really is.
It's been an amazing journey, that's for sure. Exploring the edge of what we know, maybe even pushing past that edge a little bit. We talked about the observable universe, some of those truly mind-bending ideas about how space and time work, and the mysteries of dark matter and dark energy. We even got to ponder the ultimate fate of the universe and what it all might mean for those future generations of, cosmic explorers out there.
Yeah, and I think through all of that, the biggest takeaway is this. The pursuit of knowledge, it's a journey that never really ends. There will always be more questions to ask. There will always be more mysteries to solve. And there will always be new frontiers to explore.
So, to everyone listening out there, keep looking up, keep asking those questions, and never ever lose that sense of wonder and curiosity about this incredible universe that we all get to call home. This journey of discovery is far, far from over.